Welcome to this explainer session. Go ahead and settle in. If you're tensed up, take a deep, grounding breath right now and just let your shoulders drop. I want you to imagine a clean, beautifully minimalist digital tablet resting right in front of you, set perfectly to dark mode. There's absolutely no clutter here, no chaotic textbook pages, no distractions pinging for your attention. Just a pristine, quiet space designed for pure, uninterrupted cognitive focus. Today, we're initiating a deep focus exam strategy session, and it is specifically engineered to completely dismantle your exam anxiety. We are going to calmly deconstruct one of the most notoriously complex, high-tariff areas of the Cambridge AS and A-level Mathematics 9709 syllabus. I'm talking about trigonometry, and more specifically, mastering the R forms. You know the ones. That's your R sine of theta plus or minus alpha, and your R cosine of theta plus or minus alpha. Now, if just hearing those expressions makes your heart rate spike even a little bit, I promise you are in exactly the right place. Think of me as your learning architect for this session. I'm going to guide you through this complex mathematical architecture with total serenity. Together, we're going to strip away all the noise, lower that effective filter that blocks learning, and master the exact structural layout that Cambridge examiners are actively searching for. So, let's just dive right into this. I want you to really listen to this insight because it comes straight from a senior Cambridge examiner. They noted the difference between a B and an A star in mathematics often comes down to how well you understand trigonometry. Now, what's really fascinating about that reality is that trigonometry, and particularly these R forms, is essentially a gateway topic. It doesn't just sit politely in isolation in its own little chapter. It bleeds directly into calculus. It forces its way into differential equations. You'll see a pop-up in mechanics and harmonic motion. So when candidates stumble right here on the R forms, it creates this massive cascading effect across the entire exam paper. Suddenly, Part A mistake costs you Part B and Part C. But here is the serene, objective truth of the matter. You absolutely do not need to fear this. We are going to position you for top-tier marks by treating this topic not as some daunting, memorization-heavy mountain of abstract formulas, but as a highly logical, completely predictable procedural framework. It's like a code. Once you actually see the matrix of how these specific questions are built and structured, earning that A star just becomes a matter of calm, deliberate execution rather than frantic, last-minute guessing. To keep our minds anchored and reassured today, here is our cognitive roadmap. First, we'll cover the core principles. Second, we'll map out the procedural framework. Third, we'll highlight common examiner pitfalls to keep you safe. And finally, we'll lock in our final evaluation strategy. Let's move smoothly into our first section. Section 1, Core Principles. Before we even think about manipulating the equations on the page, we really have to ground ourselves in the theoretical architecture that Cambridge actually demands from you. We are looking to build a deep conceptual understanding that you can transfer smoothly to entirely unfamiliar contexts in the exam hall. The core architecture of these R forms rests heavily on three things: precise definitions, causal relationships, and cross-topic integration. When you look at an expression on your paper, something like A sine theta plus B cosine theta, you need to instinctively, immediately know that it can be compressed into a single, elegant trigonometric wave. That compression is a precise causal relationship. But here's the real secret, the absolute game changer that elevates a paper from a standard B to a flawless A star. The principal examiner reports consistently highlight that the candidates who actively reference cross-topic connections are the ones who achieve significantly higher marks. What does that actually mean for you in practice? It means knowing that converting an expression to an R form isn't just a neat little algebra trick to show off. It's the specific required tool you need to find the absolute maximum or minimum value of a fluctuating function. Or it's the only way to solve an equation that would otherwise be mathematically impossible to crack. It's about seeing the whole board. It's about connecting the trigonometric identity directly to the calculus application that almost always follows in Part B of the question. And this perfectly illustrates the exact assessment objectives, the AOs, that are strictly demanded by Cambridge. These rest on three foundational pillars: knowledge and understanding, practical application, and above all else, analytical depth over superficial breadth. When you sit down at that desk in the exam hall, I want you to mentally highlight these AOs in your mind. Examiners do not want to see you panic and scatter a dozen random trig identities onto the page just hoping one of them happens to stick. They want to see a calm, deep, analytical strike. They want you to peel back the filler words in the prompt and find the exact command. If the command word is show that, your analytical depth strictly requires you to lay out every single logical step. You cannot skip ahead in your head. If the command word is hence, well, they are strictly demanding that you practically apply the exact R form you just successfully found in the previous part of the question. If you start over from scratch, you get 0 marks for that section. Isolating these exact demands is absolutely crucial because it systematically lowers your anxiety. You aren't sitting there guessing what they want anymore. They are literally telling you what to do through the command words. Let's transition over to Section 2, the procedural framework. We are going to map this technical methodology out using our pristine digital workspace. To really visualize this, I want you to imagine a study debate happening right now between 2 top-tier scholars. We'll call them Alex and Sam. Now, Alex is highly analytical and incredibly precise, but under the ticking clock of an exam, Alex tends to panic and crowd the page with unstructured, messy math. Sam, on the other hand, is creative and dynamic, mathematically gifted, but notoriously prone to losing focus on the specific parameters of the command words. So together, they know they need a standardized, foolproof sequence to protect their time and their marks. They establish 5 strict steps. Step 1, identify key elements. They look at a complex past paper prompt. Alex calmly points out that the question specifically asks to express the function in the form of r cosine of theta minus alpha. Sam jumps in and highlights the crucial parameters hidden in the text. R must be strictly greater than 0, and alpha must fall exactly between 0 and 90 degrees. Step 2, apply relevant principles. This is where Alex correctly and methodically expands the compound angle formula on the digital whiteboard, writing it out completely without skipping a single term. Step 3, execute analysis. This is where Sam shines, smoothly equating the coefficients of sine and cosine from both sides of the identity to confidently find the values for r and for tangent alpha. Step 4, verify results. This is a step everyone skips, but not our scholars. They intentionally pause. They ask, did we check if the quadrant actually makes sense for our calculated alpha angle? Since sine and cosine were both positive, yes, it firmly belongs in the first quadrant. Finally, step 5, present format. They write out the final, beautifully constructed equation clearly at the bottom of the page, double underlined so the examiner cannot miss it. By forcing this calm, structural debate, Alex doesn't crowd the page with unnecessary scribbles, and Sam doesn't forget the angle parameters. It is a perfectly synchronized dance of pure logic. Now, as Alex and Sam finalize their digital notebook layout, they remind us of a fundamental, absolutely non-negotiable Cambridge truth. We call it the method mark strategy. Marks are overwhelmingly awarded for the process, not just the final answer. I really need you to hear this. Structural discipline is where the real marks are won in A-level math. Strict conventions are your absolute best friend. Imagine you make a tiny, minor arithmetic error when you're calculating your alpha angle. It happens to the best of us. But if you have explicitly laid out your expansion heading, if you have used the correct terminology by writing out your tangent ratio clearly, and if you have neatly annotated your steps down the page, the examiner can and will award you method marks. A completely flawed final answer can literally still yield 80% of the total marks for that specific question if your procedural framework is flawless and easy to read. Do not just write down numbers scattered across the page. You need to tell the examiner a pristine, highly logical story of exactly how you are solving the problem. Moving right along to Section 3, Common Examiner Pitfalls. Before we break down these specific pitfalls, I want to trigger an intentional focus reboot. I want you to take a slow, deep breath in right now and let it out. Consciously release any tension you might be holding in your jaw or your shoulders. Remember, the exam hall is just a room with desks in it, and you have the structural tools to completely conquer it. Let's look at the top 3 mistakes pulled directly from the principal examiner reports for the 9709 syllabus, so you can preemptively sidestep them. First up, confusing cause and effect. In R forms, this almost always looks like candidates confusing the compound angle formula expansion. For example, they might accidentally mix up the sine and the cosine expansion, putting a plus instead of a minus, which violently alters the entire causal chain of the solution and destroys the final answer. Second, forgetting to check format and presentation. Remember our scholar Sam? Sam often forgets to check if the question asked for the angle in degrees or in radians, or Sam fails to give the final angle to exactly 1 decimal place as strictly dictated by the instructions on the front cover of every single Cambridge exam paper. Losing a mark because you rounded to 2 decimal places instead of 1 is a tragic, entirely unnecessary loss. Third, answers are not specific to the given context. If Part B of a question asks for the maximum value of 1 divided by the expression you just found in Part A, you must use your specific R form to evaluate that limit. The examiner is testing your ability to link contexts. If you ignore Part A and start the problem over from scratch using calculus, you are wasting time and losing marks. Which leads us to a really crucial mental challenge.
Why do so many capable students find evaluating evidence and drawing conclusions so incredibly hard in mathematics? It's really easy to think of math as just solving for x, right? But Cambridge A-level demands higher-order thinking. When a question asks you to evaluate the minimum value of a function and then state the exact value of theta for which that minimum occurs, students suddenly hit a massive roadblock. Their evaluative evidence just drops out of alignment. They might find the maximum instead of the minimum because they completely failed to conceptually understand that maximizing a denominator naturally creates the minimum overall value for a fraction. It's a logical breakdown, not a mathematical one. It's about drawing those solid, logical links back to the original prompt. To fix this, you must apply a structured, rigorous framework to your math, almost exactly like you would an essay paragraph. You state your core principle, you meticulously execute the math, you evaluate the given constraints of the prompt, and then you logically link your final sentence back to exactly what the question asked. Let's step into our visual satisfaction practice arena for a moment and compare two completely distinct approaches side by side. On the left side of your screen, we have the flawed approach. Imagine a student's paper where they've written down the correct R form at the bottom, but above it, they haven't explicitly stated that R equals the square root of a squared plus b squared. They've just magically jumped from the prompt to a calculated number. They have superficial breadth, sure, but they are entirely missing the structural definitions. An examiner hates this. Now look on the right side, the A-star approach. This candidate writes down the exact trigonometric identity they are using right at the top. They actively question assumptions on the page, for instance, jotting down a quick note that since both the sine and cosine coefficients are positive values, the angle alpha absolutely must reside in the first quadrant. They literally justify their decisions with written evidence on the page. When you look at a flawed student paragraph versus a pristine, high-scoring one, the difference isn't usually raw intelligence. It is entirely found in structural discipline. The A-star candidate doesn't just do the math in their head, they meticulously document their complete compliance with the examiner's mark scheme.
We've reached Section 4, Final Evaluation Strategy.
I want to introduce you to a really powerful memory hack before we finish up. We're going to use a visual story method to deeply encode these trigonometric concepts into your brain. Instead of trying to brutally memorize abstract letters and formulas, I want you to visualize a simple right-angled triangle. Picture it on your digital tablet right now. The horizontal base of this triangle is your value A. The vertical height of the triangle is your value B. Now, what is the hypotenuse? That hypotenuse is your R. And the angle sitting right there at the base, that is your alpha. The entire complex R-form concept is literally just a translation of a trigonometric wave into a simple, basic geometric right-angled triangle. So when you are sitting in the exam hall and the pressure is on, if your mind goes blank and you forget the formula for R, don't panic. Just calmly draw that little right-angled triangle in the margin of your paper. The Pythagorean theorem instantly magically tells you that R squared equals A squared plus B squared. Basic SOHCAHTOA trigonometry immediately tells you that the tangent of alpha equals the opposite over the adjacent, which is B over A. By intentionally linking a complex high-level algebraic procedure to a simple, grounding visual story of a triangle, you completely bypass the need for rote memorization. You encode the rules so deeply into your long-term retention that recalling them becomes utterly effortless. So, the crucial point today is to distill this entire extensive masterclass into 3 core unshakable focus pillars. Number 1, the 3-step question scan, or decoding. This is where you peel back the filler text, identify the exact assessment objectives, and isolate the command words before you ever even pick up your pen. Number 2, the marks per minute flow formula. Remember Alex and Sam's flawless 5-step procedural flow. Establish your structure, apply the relevant principles step by step, and protect your precious exam time by explicitly chasing the method marks rather than just rushing to a final answer. And number 3, the final polish review pass. This is your safety net. This is where you consciously avoid the top examiner pitfalls. You check your calculator, are you in radians or degrees, you visually confirm your quadrant assumptions using your signs, and you ensure your final answer is flawlessly, beautifully presented in the exact specific format requested by the prompt. Decode the question, flow through the procedure, and polish the presentation. Before we wrap up this deep focus session, I want you to pause and make sure your daily study dashboard is actually complete. Go ahead and subscribe to @AceTheExams right now and make sure you enable all notification alerts. Picture that minimalist little bell icon lighting up on your screen. Whether your current target is an IGCSE, an O-level, or securing that elusive AS and A-level A stars, this channel is your dedicated weekly space for calm, stress-free exam mastery. We are actively building an elite community of focused learners who approach these exams not with dread or fear, but with serene, highly calculated strategy. Make sure you are a part of it. I am going to leave you with this final provocative thought.
As you step away from this digital workspace today and transition back into the noise of your daily routine, I want you to ask yourself, what specific subject, tier, and target grade are you currently meditating on? Are you intensely chasing that A-star in 9709 pure math? Or are you architecting a top grade in another discipline entirely? Drop down into the comments below and literally write it out. Putting your specific exact goal into words for others to see is the very first step in structurally executing it. Stay deeply focused, stay incredibly calm, implicitly trust your procedural framework, and I will see you in our next masterclass.